ships at sea today with as many technical specifications and engineering installations. The one thing that is common to all of them is that they will require the use of water, one way or another. It may be used for steam production or engine cooling, or simply for consumption by the officers and crew. In fact, water will be used on board in considerable quantities. Fortunately, there is always plenty of it available in the form of seawater. You can pump it and use it straight away for washing the deck, for example. But if you try and use this water in the boiler, or for cooling your main engine, in a few days, catastrophe will hit the ship. The boiler could blow up, or the main engine break down. This is because seawater is contaminated by dissolved and suspended solids. Sodium chloride, calcium and magnesium carbonates, and calcium sulfate. These form deposits which can cause overheating and mechanical breakdown, making it unsuitable for use in boilers and in engine cooling systems, just like it's unsuitable for drinking by human beings. That is why the cleaning and treatment of water on board ship is so important for the ship's efficient operation. And that is where chemical water treatment plays a vital role by preventing internal corrosion and scale formation. Chemical water treatment. Getting it right means much reduced operational problems. But get it wrong, and you could be in danger of paralyzing your ship. Maintaining the required quality of water, therefore, is critical. For that reason, chemical treatment is one of the most important safety functions on board ship, because it guarantees the safe and efficient operation of the two most important energy-providing installations, the main engine and the boiler. If these were the impurities which made seawater unsuitable for use in boilers and in cooling systems, it stands to reason that removing them must be part of the function of water treatment. But that's not all. There is one other component in seawater which, for our purposes, is an unwanted impurity: dissolved oxygen. The reason for this is simple. Oxygen and water, if they enter the crystal structure of steel, will cause corrosion. Water absorbs gases from the atmosphere, such as nitrogen, oxygen, and carbon dioxide. Oxygen and carbon dioxide together are very corrosive. Prolonged corrosion weakens the steel, so that boiler water pipes could burst, pistons break, cylinder linings become damaged, causing mechanical failure. This situation is even worse in the case of boilers, where the rust acts as a barrier, inhibiting heat transfer. So this oxygen content must also be eliminated chemically from the water to be used in boilers and engine cooling systems. In the case of high-pressure boilers, the situation is even more complex and critical. Chemicals are delivered to the ship in accordance with decisions made by the superintendent and the manufacturers. Once the chemicals have arrived on board, the first task is to store them safely and securely. This includes the safe segregation of incompatible chemicals. The manufacturers will have provided all the safety instructions with the chemicals, and should also have recommended the best methods of storing them. This is most important, even if you have used the chemicals before on other ships. Every ship is different due to the particular equipment mix on board. Therefore, each is requiring their own particular water treatment in accordance with company policy and the manufacturer's recommendations. Do not assume that a familiar chemical treatment used in one type of equipment will be used in the same way in another. Take your time in getting to know the chemicals used on your ship. Now get to know the test equipment, the various reagents, and the test procedures recommended by the manufacturers. Check the expected correct values for each test. Check how the records were kept by your fellow engineers before you. Are they fully informative? Do they provide the correct information? And most important of all, get to know how to interpret the test results and what actions must be taken if the tests indicate that corrective action is required. It's surprising how often the correct tests are taken and then the results ignored, as no remedial action follows because the meaning of the results were not clear. So this is the time to get to know the tests themselves, the expected normal readings and the way abnormal readings can be identified and acted upon. Do not leave anything to chance. This is a responsible job requiring thoroughness and attention to detail. The evaporator is the first installation which cleans and treats the seawater on board. It produces distilled water by evaporation, reducing the contaminants to less than 4 parts per million. The quality of distilled water produced by the evaporator will determine the type and quantity of chemical treatment required for all other water-using installations on board. Inside the evaporator, water is both evaporated and concentrated. The first requirement, as far as chemical treatment is concerned, is to ensure that the impurities present in the seawater are prevented from depositing inside the evaporator and are capable of being dumped from there. The second job is to prevent foaming, which can lead to carryover, impurities being carried over into the distillate side of the system. Both these tasks are achieved by adding the required anti-foam and scale inhibitor treatment to the seawater entering the evaporator. In this case, MaxiVap Plus. The dosage depends on the daily output of the evaporator, and a table of recommended quantities for the chemical treatment will provide this information. The effectiveness of the chemical treatment in producing good quality distilled water is monitored by an alarm, which is set to warn if the level of salinity reaches a preset value. Engine and compressor cooling systems invariably use the distilled water produced by the evaporator. Because distilled water contains little hardness salts, scale deposition is not a major problem. The primary concern here for chemical treatment is the corrosion we described earlier. Besides normal rusting, there are other corrosive processes which may take place in this hot environment. Erosion, leading to cavitation, pitting, galvanic and microbiological attacks. Inspect all systems on board if more than one exist. The chemical treatment for cooling water inhibits these corrosive attacks by forming a protective coating on the metal surfaces inside the system and chemically neutralizing the acids. Periodic tests of the cooling water quality must be carried out to check the acidity level inside the system. For this purpose, good representative water samples must be obtained. The sample point must be flushed before a sample is taken to ensure that the water inside the sampling line is representative of the water inside the system. This test must be carried out without contaminating the sample. Most tests involve counting drops of reagent. The pH test uses a test indicator, MPa1, to indicate a general alkalinity level. After adding 2 to 4 drops, the normal sample should turn pink. This means that the pH is above 8.3. pH is a value of acidity or alkalinity on a scale of 1 to 14. 8.3 pH is slightly alkaline. If the sample does not turn pink, the pH level is less than 8.3. The system should be dosed to increase the pH level to just above 8.3. After a dosage, the test should be carried out again when sufficient time has been given for the alkalinity in the system to stabilize. The test results must be interpreted and understood, and the condition of the cooling water modified, if need be, to re-establish the correct water quality. Some installations rely on corrosion inhibitors as well, such as sodium nitrite. A test kit is available for determining the level of nitrite inhibitor in the cooling water. A measured quantity of sample water is dosed with 4 drops of Mn1 reagent and turns red. Following this, drops of Mn2 reagent are added and counted whilst the sample is shaken. When the sample turns from red to blue, the number of drops required to achieve this will indicate the nitrite level and any consequent chemical treatment dosage required. A chart is available for reading off the recommended dosages. The most important and the most complex control of water quality concerns the boiler water. Successful boiler water treatment depends on the use of the right chemicals in the right amounts applied correctly. To achieve this, the boiler water test must be carried out regularly and correctly, using a representative sample of the water. When taking the sample, the line should be run for a few minutes before a sample is taken. In order to understand the tests and the job for the chemical treatment of the boiler water, we should have a look at what happens to water inside the boiler. Under operating conditions, carbon dioxide is formed in the boiler, which is turned into carbonic acid in the condensate system. Traces of oxygen in the water make this acid even more aggressive. The chemical treatment, therefore, has 3 functions inside the boiler. Firstly, it must scavenge the oxygen in the water system. Secondly, it must neutralize the acidity. And thirdly, it must prevent scale formation. The tests have shown that an alkaline treatment liquid and additional oxygen scavenger are required to minimize corrosion and to prevent the build-up of scale. The correct dosage is measured out and applied accordingly. After sufficient time has passed for the chemical treatment to enter the circulation, and the chemicals have had time to work inside the boiler, another test result indicates that the desired condition has been achieved inside the boiler. Chemical control of water quality by the application of water treatment is a vital safety measure for the ship and its personnel. Anyone entrusted with this responsibility must be thorough, paying attention to detail, particularly to test results, and following up with corrective action any reading which indicates an undesired water quality. Taking good representative water samples, carrying out the tests correctly, preparing the right amounts of the correct chemical treatments, and dosing in accordance with the supplier's recommendations are equally important and vital procedures of chemical water treatment. Remember, some treatments are added daily or at other set periods. Other chemicals are only added if the test results indicate abnormal readings. Common sense, cleanliness, and good record keeping, coupled with attention to safety in handling, storing, and dosing chemicals, will contribute to the satisfaction which comes from a job well done.